So let's take a look at how we can calculate this confidence interval for a population proportion by using the bootstrapping method. So in this question it says, in a study of the accuracy of fast food drive-through orders, a restaurant had 39 orders that were not accurate among 360 orders observed. So that proportion right there would be 39 out of a total of 360. Use the bootstrap method to construct a 95% confidence interval estimate of the proportion of orders that are not accurate. Use the 200 accompanying bootstrap samples. How does the result compare to the 95% confidence interval given here? Okay, so first let's go ahead and open up our bootstrap samples inside StatCrunch. I'm going to go ahead and click on this little blue icon, which will open up the data. And then I'm going to click on this little blue icon and choose to open in StatCrunch. So what I've been given here, let's move this over a little bit, is all the different numbers of orders here in the second column that were not accurate. And if we remember, let's move this down for a second. Whoops. This was out of 360 orders total. So what I need to do is first I need to figure out the proportion of inaccurate orders for each of these samples. To do that, I need to take each of these numbers here and divide them by 360, which was the total orders. To do that, I'm going to go here to this third column and I'm just going to create a formula that goes to each one of these numbers in the second row and divides that number by 360. I can do that by going to Data, Compute, Expression. And then I'm going to click on Build to build my expression. So what I want to do is I want to take the number in the not accurate column and I want to divide that by 360. So if I come right here, I can double click on not accurate and see the words not accurate in quotations will pop up in my expression line. That means that for every row that I'm on, this formula is going to grab the number that's in the not accurate column in the same row. And then I want to divide this by the total, which was 360. I'm going to go ahead and say OK. And I'm going to label this column Sample Proportions. You don't have to label it if you don't want to. And I'm going to click Compute. So now, we don't need this. StatCrunch has given me the sample proportion of inaccurate orders for every single one of these samples. So now what I need to do is I need to figure out my confidence interval using the bootstrap method from all of these sample proportions. Now, I was looking for a 95% confidence interval. Let's remember for a second what that's going to look like. So for confidence intervals about a proportion, we were using the Z distribution, which is the standard normal distribution. That means that if I were to graph this distribution, I would get that nice bell-shaped curve, like that. Well, a 95% confidence interval means that somewhere here in the center of my graph is 95% of the data. And there's some value here and here that separates off the remaining 5%. So 95% is in the middle, and in the remaining tails, here and here, are the leftover 5%. But since there are two tails, that means that 5% needs to be split evenly, half going into the left tail and half going into the right tail. So if we take 5% and we divide it by 2, what we get is 2.5%. So the left tail has 2.5%, and the right tail also has 2.5%. So when we go to do our bootstrapping, we need to find these two percentiles. To get the lower limit of our confidence interval, we need to put in 2.5 for our percentile. Because we want to find the point on the graph, right here, where 2.5% of the data is less than or to the left of that point. The second percentile we need is for this point right here. This percentile is going to be the 97.5th percentile. Why is it 97.5? Because again, to find this value for the upper limit of our confidence interval, we need to know what area to the left of this point is present on the graph. Well, that is this 95% plus this 2.5%. So all together, it's 95% plus 2.5% is 97.5%. So our two percentiles that we need for this 95% confidence interval are 2.5 and 97.5. Back to my StatCrunch. In order to find the percentiles, I'm going to go to Stat, Summary Stats, Columns. I want to get the percentiles for that column that I created of these sample proportions. Now if I scroll down, some statistics here are already selected. I won't be needing those, so if I want, I can just unselect most of them. If I scroll down, here in the percentile section, I need to put in those two percentiles that I wanted. So that was the 2.5th percentile, and then we separate with a comma, and then the 97.5th percentile. And I will click Compute. So here is the lower limit of my confidence interval, 2.5 percentile, and the upper limit right here. So if I just transfer those over, this should be the 95% confidence interval that I got from the bootstrapping samples. Correct.